AI is changing the way we all work, and technology professionals are no exception. The availability of GitHub Copilot, Claude Code is changing the way we work with the machines as we're coding. And so I'm very pleased to discuss the future of software engineering with Manjunath Bhat, distinguished VP analyst at Gartner. Welcome, Manju.
Thank you, John. Thanks for having me.
It's a pleasure to talk to you, Manju, always. You've been a keynote speaker at API Days Singapore the last couple of years and also recently at API Days Australia. And I know that you've done a lot of research about software engineering and you're tracking very closely the changes in the way we do software engineering. Can you sort of give us a picture of what's been the most dramatic change that you've seen in the last year or so?
Yeah, I think that's a good place to start. And I will call out, I think, for the purpose of listeners to this podcast and who may not be familiar with what I do or what our team does. So as you said, I'm part of Gartner's software engineering practice. And one of the many analysts who focus on the impact of AI on software engineering, plus also the other side, which is how you're starting to see a new software development lifecycle emerge for AI. So literally, we're seeing this play out in two ways. What we're calling AI native software engineering, which is impact of AI on the traditional SDLC, and then the rise of what we can think of as the agent development lifecycle, or the ADLC, which is the SDLC for AI. I think with that background, one of the big shifts, if you ask me, John, I'd call out, I think this big shift in the last few years has been where software engineering has moved primarily from being something that is human driven but AI augmented to being now agent driven and human augmented. So I think that is at the core of many of the subsequent shifts we are starting to see. And when I say AI augmented versus something that's driven, think of this as like when this entire wave started, it almost felt like, well, we'll continue to work within our IDE, right? So, and you'd have these developers actually tabbing through function. So function was the unit of change. And so I think as we started moving from just like these tools, like suggesting functions, to now implementing entire functionality, right? So that at its heart is the shift from AI moving from being an assistant to being a long-running agent, right? So, I mean, metaphorically, people have said, well, agents have become co-workers. So we are sort of less inclined to use that term because on one hand, it denigrates the real meaning of what is a co-worker, right? So, and even we've tried to stay away from the term peer programmer, because if you think of those actual human terms, you'd assume that humans actually, we improve learning from our peers. Right? So there's a very healthy learning loop, but these agents, at least until now, they don't demonstrate online continuous learning. So which is why we still prefer to call them like long-running agents. So I think if you ask me, the big shifts, like I discussed, like human-driven to being agent-driven, I think the other thing is also what this has meant is that it's also, I think on the positive front, you can think of humans are now like, as in, we are able to, this paper, right? Backing up, attention is all you need was this transformative paper on transformers. Well, what that also means is human attention is not only important, and it's human attention is actually a scarcer commodity, right? Attention in that paper referred to something else, but if we now look at the impact it has had on the way we work, it's not just knowledge that is it's important, but where we drive our attention, right? So and I think with these long-running agents, what it has enabled we as humans to do is it's enabled us to direct our attention in areas that matter most, whether it is in terms of business impact, if we are in the corporate world, or if we're working on a hobby project, we can just get to some desired outcome as soon as possible, right? Just completely eliminating friction in the process.
I think from what I've seen, every programming course I've ever tried before or in the last 30, 40 years, every programming course has always started with a hello world application. It sounds silly to only put up hello world on the screen, but in the past, it's been very difficult to get to Hello World because you have to set up an entire environment. You have to understand the syntax. You have to get that syntax right. And the early compilers, interpreters would punish you quite severely for not getting it right, and you just get syntax error or no response at all. But you can get to Hello World now with one of
Pretty
these
quickly.
AI
Yeah.
coding assistants almost instantly. And I'm interested in your comment about pair programming, because pair programming is about a dialogue between people, peers, who exchange ideas, and the sum is, the whole is greater than the sum of the parts. You can get a conversation out of an AI coding assistant, but I think your point is that it's more like an assistant or I've heard some people describe it as an enthusiastic intern. They won't always
Yes.
get it right. They can come up with some exciting things. They're always interested in creating something, but it won't necessarily be the right thing. And you have to adjust and make it go back and backtrack a few things. And I guess use your own expert knowledge of what good looks like in order to iterate with the coding assistant to get to where you want to go, following the best practices. That, is that where you see things are now, or and more of that, or where do you see this
Yeah,
heading?
I think if we think about it, like you said, AI has made it very easy to build a prototype. I think the real gap is from taking a prototype to production, and which is where we still see a lot of friction. So I think completely agree that if you just want to build a Hello World program, it's become a no-brainer. In fact, it has lowered the barriers, which is why it's a good sign for the industry, because you can have so many, even people from outside the traditional tech sector, right? So, and people who would have thought, oh, this, programming is something that's an arcane kind of technology, and probably, outside of my realm. Now it feels within reach. And even within the tech sector, you find that product owners who might have stayed away from development, thinking, well, if I all I can do is build a wireframe, but with these kind of tools, now they can go beyond a wireframe and see something actually working, right? So in many ways, it has bridged this gap between different roles. So between product owners and engineers, plus also for engineers, I think the biggest benefit, I think this is an important one to call out, is that it's dramatically improved the pace at which you can experiment, right? And so the cost of experimentation is almost like hitting zero. You can try out n number of experiments with almost zero cost, and then decide, okay, this is the path I'm going to go to. And taking that prototype to production is where all of the friction lies. So that's maybe one way to think about this. And the other comment about pair programming is still, if you look at, for instance, where pair programming really becomes valuable is it's one human judgment versus another's human judgment, right? So I think this is the essence of the difference, where what you'll start to see is increasingly with these agentic workflows, it's making coding a very execution focused activity. So the value is no longer just in the art and science of producing that code. So the value of implementing something is becoming lesser and lesser. Where there's huge value is like in the what we call executive function. So think of this as humans being valued not as much for execution but for executive function. Now that executive function can manifest itself in good decision making, good judgment, your ability to sense whether this is the right thing to building like customer trust, user trust. And if we look at pair programmers, this was really two humans exercising this kind of human judgment. With agentic workflows so far, right? It's still like you don't get the same feeling that you are looking at another person's like human judgment. So which is why I sort of hesitate that. And in fact, that one of the big downsides, if you look at in recent times, there's been this huge trend about vibe coding, right? One of the downsides of vibe coding is also for the developer, there's no quick iterative learning mechanism in place. So you don't, because with vibe coding, you assume that you don't care about the code, which is why it's really good for building prototypes. But for production grade software, you do want the human developer, the person using these tools, to also improve, right? And not only that, you also expect that the tools will improve, which is, I think, a twofold downside to this process. It's a limitation right now that by completely offloading work to an AI, we are not learning in the process unless we consciously choose to. And the other limitation with these LLM models or AI or agentic coding tools is it's not learning continuously either, right? So that is where most of the new like infusion of innovations is happening, John. So if you look at, maybe if you ask me, where is the broader surface area of innovation, I'd say context, right? And which is why like context engineering is important. And so in many ways, we started with these tools like essentially become innovating at the experience layer, but fast forward now and in future, you'll find that if they have to continuously improve, they got to innovate at the context layer, right? So context layer becomes the new innovation surface.
So I find it's certainly a productivity improvement, and I'm not a great fan of hand coding HTML, CSS. So the coding assistant certainly takes away a lot of that legwork to set up a page or a set of functions. I guess to your point is the context really has to come from me as the coder. I have to say, not only do I want a page that has these characteristics, but it has a particular purpose. And then I've found, well, it does accelerate the cycle,
Yes.
because even if you were hand coding everything, you would start with a small program and then start to add functions on top of that, because you need to be able to test as you go. No point writing 10,000 lines of code and then start testing. It's not going to work. You have to test a little bit. So that there is still a cycle that you should go through, a build, test, learn cycle. But I think to your point is that it's up to the human to tell the assistant, you need to start heading in this direction. And I haven't found, when I've said, well, actually that file's getting too big, can you break it out into 2 or 3 files by function? Or there are some hard-coded variables there.
Yeah.
Can't you create a configuration file? That configuration file is not protected anywhere. It's exposed in the repository. Can you put that? So having to constantly remind or ask the assistant to build out something that's going to be more secure, more scalable, more production ready is still on the expert. So where do you see our expertise going into, though? You talked about executive function, but the executive function is sort of thinking a little bit about the context, but it's also having an understanding of what is compliant, what is secure, what is scalable, what's cost effective also for the company.
Yeah, 100%. So I think few thoughts responding to that. One, if you look at recent trends that have surfaced to mitigate those kind of issues that you mentioned, one primarily is spec-driven development. So I think that has emerged as one of the ways where you can overcome the limitation of traditional vibe coding, where it was primarily meant as a stateless interaction mode between the developer and the assistant. And as soon as the developer exits the session, all context is lost, right? So that was a huge limitation. So you're not like essentially giving sufficient context to the agent. So with specs, we can think of specs as a mechanism to steer the agent to do what we expect it to do. Now, it's not necessarily meaning that it's spec driven development, and not necessarily that the agent, because it's non-deterministic fundamentally, you can't expect it to be a spec fulfilling agent, right? So I think we got to maybe set that expectation that just merely by creating a specification, we can't guarantee that the agent adheres and complies with that specification. So it's just a way for us to ensure standardization. It's a way to ensure consistency, right? So governance rules are in place. I mean, I am starting to look at specs in a twofold manner. One is, if you are, let's say, a platform engineering team, if you are part of the security and risk team, you want your governance policies codified. And what's the best way to codify and institutionalize those policies? Well, that would be specs. So you mentioned Claude Code, so you might put that in a .md file for Claude and all of the markdown files, right? So that becomes a vehicle to, in fact, serve this twofold purpose of improving developer productivity plus also meeting governance needs, right? So I think that's one huge benefit. The other thing that also becomes important is You know how, like, I think going back 20 years ago, one of my favorite books was Martin Fowler's Refactoring. He's one of his very popular books as well. And I almost thought that, well, has refactoring gone out of fashion? But in fact, you can think with AI augmented or AI native coding, refactoring might actually see a resurgence, right? So it's probably refactoring has never been as important because as AI keeps like generating more and more code, we got to compensate for all of the newly generated code to make sure it's also continuously refactored. So I think that is extremely important. And who does the refactoring probably, is a moot point. That you can still direct the agent to refactor code, but refactoring is important. The other thing that also becomes important is verification and validation, harnesses. So when you have such a huge amount, such a huge volume of new code being generated, it's just implausible, right? So I mean, it's unthinkable that you can just have humans verify every line of code that is being generated, or like, you just can have human in the loop and human oversight. It's good in theory, but you would very soon find humans as the new bottleneck. And so if we got to overcome that, what might need to happen is our like the success with these AI, agentic coding tools is directly proportional to the degree to which we have a very high degree of verification and validation maturity. So which means fast inner loop will also require a faster outer loop. So I think that is how I'm thinking about it.
So you touched on some things, and I guess we started talking about individual programmer productivity, and now you're talking about what it means to the enterprise, because the enterprise needs to enforce some standards. They should encourage certain patterns to be used, if only for the sake of readability by other developers, but also to your point about validation. And in a sense, before generative AI, we were automating testing. We were setting style guides for an organization. Architects would create patterns and even anti-patterns. Don't do
Yeah.
this to an organization. But it would have to be enforced manually because manual code reviews are very, very time consuming and no organization really gets to do it 100% of the time. And the linters that have been used to verify compliance with a style guide, there are often, then it still requires a judgment because there's a tension between standardization and innovation. Standardization is very valuable because you can validate things, you can verify that things are not going to go out of control, but you'll only ever get the same as what you had before. You won't get new things unless you innovate. So the linters that were put in place, they may come up with identify a violation of a style guide, and then some senior engineer would have a conversation with the less senior engineer about why they should do that, or should they really conform with a pattern. But for organizations to manage that, I guess what it means is it's not enough just to automate a simple rules-based system. You have to get another agent to look for what can go wrong with this. Where do you see that evolution occurring? Is that going to be built into the tools, or do we need an external set of tools that
Oh
are
yeah.
going to...
I think a couple ways this will start to unravel is that even now when we're looking at our IDEs, and by the way, my favorite like acronym, like think of this as mutating an acronym, is I say IDEs are not just integrated development environments; they're now intelligent development environments, right? So that's the new IDE, if you will. In these intelligent development environments, it's no longer just assistants. We've gone from assistants within the IDE to single agents. But to your point, John, coming to what you're describing is these are multiple agents. So if you look at tools like whether it's Amazon Kiro and Cursor and few others, they've started using the term sub agents, right? So it's actually an orchestrator agent that spins off like and works with orchestrates a bunch of sub agents. So you can sort of imagine that there are sub agents who will keep a watch on what the other agent has produced. So in a sense, one sub agent is going to verify the code of another sub agent. If we are worried about agents grading their own homework kind of a problem, I think what this is also coming out to be is that you will not just have like one model. So maybe you use the developer or the coder sub-agents to use one model, maybe a GPT 5.2, 5.3, and then the verification sub-agent could be a Claude model, right? A Claude Opus and so on. So in that sense, you're still taking advantage of agentic verification without just maybe like just overly relying on one model doing it all. So that's one thought. And the other one is, I think on the positive side, I'm starting to see how a lot of the knowledge used to be considered tribal knowledge. Everything that exists maybe in a senior engineer said, we resorted to maybe using Confluence and a few other tools to institutionalize that knowledge. But it generally became a very passive source of knowledge for the organization because there was no good way to weave that knowledge residing in those sources of truth or systems of record like Confluence, right, and weave that in. So which means you can think of agents as a mechanism to institutionalize tribal knowledge, so which is huge, right? And so I have actually had calls on this topic where people are starting to think where as soon as this, maybe as people start to retire as senior engineers, senior architects, there is a risk of them retiring from the workforce. How might you think of retaining all of their decades worth of expertise that one they have gleaned and they're yet to contribute? So in many ways, you can create like a digital twin of John Shield, right? With your decades of experience, have an agentic version of yourself. So even after you've retired, junior engineers can tap into your expertise, right? So I think that's a huge bonus point. The last one actually that comes to mind in that in the enterprise is I was also thinking where when DevOps came along, when it became DevSecOps, it was more about like how you wanted to bridge silos, right? And that was more of an operating model shift. But if you start looking at agents, now agents can actually start to bridge these silos between teams that otherwise might not have communicated. So I look at maybe, there's a DevOps agent that's having visibility into production issues, and it's passing on all of the insights to the development team saying, hey, this is a problem with the architecture that you currently have. Right? These are the kind of issues I'm seeing every day, and I'm probably fixing it on your behalf, right? So you better do this at the architect, take care of this at the architecture layer. Or maybe security teams have a use case. You might essentially say, if you look at vulnerabilities being fixed and determined, you can have those agents actually pass on that feedback to the security team who should have participated in threat modeling, right? So in effect, you'll start to see the agent as a common, like it's a common war room that is a virtual war room where it's bringing folks from architecture, development, security, and ops together who might have otherwise not communicated.
I think that brings to mind practices that people have promoted, but not so easy to put into practice. So publishing a standard or a style guide or a pattern or an anti-pattern, documenting things that only served a purpose if people would read those things. And in an organization, it was often very hard to get people to read and understand and follow all of those things. And then finding the right pattern to match up. So the practicality of that is improved by having agents who can help you to locate it in a more conversational way. Tell me what the pattern is when I'm trying to connect these two types of systems together. And we talked about platform engineering in the past and the idea that a platform is set up by the operations team to help guide the development to produce good code in the first place. But that is always a challenge to push that feedback loop back through. And I guess what you're describing is agents being able to facilitate that. So what do you see as a good platform engineering practice now?
Yeah, so in effect, I think this is probably the best time to build a platform. So in effect, so basically twofold impact on platform engineering teams. One, I think my other mutation of the acronym is IaaS, so where it's no longer just infrastructure as a service, it's intelligence as a service. So I think that internally is starting to play out. We did a case study with Verizon. We have also done another one with a healthcare services provider called Vizient, right? So in most of these large enterprises, you're starting to see platform teams actually step up, one, to make it easier to embed AI as part of the SDLC. That's one part, but also like we discussed, SDLC for AI. So that's, I think, the second part of it. Now, the way platform engineering teams can use this is it's in many ways, I think, using guardrails. So platform engineers typically found it very difficult to enforce these governance policies, but they resorted, I think the best way, the best tools they had at their disposal was templates, right? So if you look at the likes of Backstage, which is famously used for just allowing templatized workflows, right? So if you want to build maybe a new Node.js service, a new microservice, use this template, and you can spin up like a hello world service very quickly if you use templates. And the benefit of templates is that on one hand, it complies with what the platform engineering team needs, but on the other hand, it also like just improves developer experience. So I think these kind of templatized workflows was the only tool that the platform teams had. But now if you look at agentic tools, yes, you'll start to see, well, of course, they will have to permit the use of agents, but what you'll start to also, I think the big responsibility on the platform team is governance of those agents. And I think, when I say governance, I mean, it's not just from a security perspective, also looking at, for instance, how much is it costing the organization, right? So I forget the actual source. Somebody said that you're not doing enough, you're not utilizing AI to its fullest potential unless you spend $1,000 per engineer, right? So I think now it's costing a lot as well when you use these tools, and with every new release, by the way, of Anthropic Claude, the cost just tends to go up, right? It's not coming down. So the better the models, the greater the reasoning capabilities, those all come at a cost. I think in short, there's huge there's a huge need for platform engineering teams to establish one guardrails, but also put in place governance around costs, governance around like expected reliability, scalability, and essentially all of the like non-functional requirements that a service should meet before it gets to production. So in effect, I think platform engineering teams now not only have to govern the way traditional like software is being developed, but they also have to govern the tools that will produce these artifacts. One last comment, by the way. So I think since you brought this up, I've been noticing a pattern with these mismatches. And I think this is where this might be an opportunity for platform engineering teams to work closely with product teams. And when I talk of mismatches, I'm referring to, let's say, for instance, this cadence mismatch. So the cadence mismatch is productivity versus security, right? So that's been a huge mismatch there. And one way to bridge or close that gap is platform engineering, to the rescue. That's one way to think about this. The other is, you can think of it as an impedance mismatch. So impedance mismatch is, if you look at what we expect from applications is deterministic, but the tools we're using to build those applications is actually non-deterministic. So it's fundamentally an impedance mismatch between a non-deterministic tool and our expectation for it to produce deterministic artifacts, right? So that's another mismatch that the platform engineering team has to resolve. And the third one is fundamentally accountability. Like you made a point earlier on where you said the accountability still has to sit with the human engineering team, and that is absolutely true. So there is this accountability mismatch where agents are doing a lot of the work that we would otherwise have done, but we are expected to continue to take accountability even if we have not done the work, right? So that actually places an enormous like burden of accountability on us, and we may not be intimately familiar with everything that's gone into building that artifact.
There's a whole lot there that I could take apart, Manju. I mean, you mentioned cost, and I think one of the things we should be a little concerned about is, yes, you can use an AI coding assistant to produce just about any code that you want, but sometimes it's using a hammer to crack a nut, and it's an expensive hammer at times when it's just churning through doing things that are really quite simple and you could automate. And sometimes I feel you probably should use the tool to produce a program that will do the thing that you want to do, rather than get the AI agent to actually complete the task, because it's going to use up tokens to do it, whereas a program can repeat itself over and over again at much lower cost without consuming all those tokens over again. So are we in danger of seeing what happened to cloud computing, where everybody thought it's so much cheaper because you only pay for what you use, and then everybody started using to do so much more? What sort of controls do companies? You mentioned platform teams. Is it just the platform team, or is it the finance team as well? What does
Yeah.
the finance team in an enterprise need to understand now about how to manage the use of these?
Yeah, I think overall, if you look at it, let's tackle the last point you made. Platform team serves as the abstraction layer. I'm using this term very loosely. So it's taking what the finance team wants the organization to do to stay true to, right? So it converts the needs of the finance team and translates it in a self-service manner to how the engineers can consume the platform. So it's basically saying, well, you engineers, you can use all the autonomy you have, but work within the financial guardrails that we have put in place. So in effect, the platform engineering teams becomes the translation layer between what the finance team wants and what the engineering team wants to accomplish. So I think we are good on that front. And you can have cost guardrails, you can have cost visibility. So all of that will play out nicely. Then the other consideration, I think the other point you were referring to is on the precursor or the precedent we have with cloud computing. And I think that is fascinating. And if we want to extend that metaphor and that example, yes, and much the same way as people eventually realize that moving to the cloud is not just for cost reasons, right? So in fact, we doubt that anyone who's maybe using cloud in the right sense actually has managed to decrease its usage. Eventually, everyone's cloud expenses go up, right, and not down. So especially if you're trying to innovate, right, and so on. So cloud expenses will shoot up. So which means much like cloud became a business enabler, and the true value of cloud only comes when you can use the cloud to drive innovation that you would have otherwise not been able to. Very similar parallels exist in the AI world. So it's probably very unlikely that somebody is going to use agentic coding tools to reduce costs. On the contrary, they might use agentic coding tools to drive new sources of revenue, or to build stuff that might have otherwise seemed infeasible, right? So something that would have been, from a business perspective, very unviable, right? So I think if we're just limiting the use of agentic coding tools to doing what we have always done, the cost implications are going to be huge, and we might not be able to justify it.
Thanks for sharing that, Manju. I think there's a lot to unpack in that, and great perspective on how our lives are changing. Can I just perhaps, as a final question, ask about where we're going to sit? Because what you mentioned shouldn't be seen as simply a cost play, just as cloud computing, to reap the real benefits, wasn't just about costs. One of the challenges at the moment is that some firms have decided they don't need as many developers, and that typically means they don't need as many junior developers. We both have children who just started university, and the immediate future for a junior engineer seems a little uncertain at the moment, because senior engineers can get more done when they would have passed on some of those easier tasks to a junior engineer. How do you see us gaining the experience necessary to be productive in order to be useful in an organization and to be employable in an organization?
Yeah, and like you mentioned, John, I tell my son who is in university now, who's in general, fundamentals are definitely going to be important. So the need for fundamental understanding of how software is engineered is not going to go away. So I'm very bullish on that. So that's one point I'll make, regardless of how software is being built, right? So engineering software is, if we assume that it is an engineering problem, the need for like foundational engineering concepts, which is whether it's architecture, design, security, reliability, resilience, right, failover, redundancy, those I think become increasingly important, not less important, right? So that's one point. I think the other thing to keep in mind, and especially if we have junior engineers or somebody who's in university listening to this, what they should not assume is that the next generation of software that we will build will bear a lot of resemblance to previous generations of software. So it's not going to be traditional, unintelligent, rule-based software, right? So it's not just automation software. So the nature of applications themselves will change. So which means we got to just prepare for the world where every application is going to be intelligent by design. So I think that is the new reality. And so it's inevitable that maybe if you're looking at today's job descriptions, you'll find there's huge demand even now for AI engineers, right? Those job descriptions ideally should have been for a software engineer who knows AI, who understands AI engineering, or who can implement AI engineering. If you fast forward maybe a few years, we can basically see the blurring of these lines. Every software engineer will implicitly be expected to be an AI engineer. So there's not going to be a distinction between a software engineer and an AI engineer, which basically tells if you're in university, just know that you are entering a workforce that expects you to be an AI engineer and not necessarily a software engineer. So that could be another thought. What else? And I think the other thing is, for instance, creativity, the foundational like human skills, those are going to continue to remain core to what we do. Like if I go back to my like example of we'll continue to use tools. Tools will get better at execution. What we'll really get paid for will be our executive functions, right? Curiosity, critical thinking, creativity. And in fact, we have like a position that we actually published in our recent report where we say that it's creativity and not productivity that's going to be the yardstick for measuring engineering excellence. And maybe that's a good thought to end on.
Mm. Thanks very much for sharing that, Manju. Always a pleasure to talk with you. And I'm looking forward to your keynote at API Days Singapore on the 14th and 15th of April. Thanks very much. And see you again soon.
Likewise, John. Thank you. Have a nice week ahead.